So let's get the molar mass of this compound. Sodium is 23 times 2 is 46, plus carbon is 12, and oxygen is 48. 48 plus 12 is 60, 60 plus 46 is 106 grams. Right? I'm going to do the rest of the math on this side because obviously some of you can't see it because it's further below. Or if I write it on this side further below, then you just still can't see it because of my computer and the table. So again, I will give you probably this on the first page, but then the calculation part you have to do. So you have to find two things. Moles of solute is, you have to calculate it, which is, again, same format. I am not changing anything. You're going to do exactly what it said. You take the given information, which is, solute is typically given in grams, and you can look at two numbers that's given in a problem and decide which one is small. Usually the solute is small. Is it 5.3 grams? 5.30 grams of sodium carbonate. Again, we put 1 here. We don't want grams, we want moles. So we put that 106 grams on the bottom. 1 mole goes on the top. That's it, we're done with the moles part. So what does this number come down to? 0.05? That's our moles. Okay. That means we got the top part done. Okay? Good. But keep in mind our unit, moles is same as mole. If you write it this way, this is the same as writing moles. These are the same. R, I want to write both. Doesn't make a difference. They both mean the same. Okay? So we got the top part of our calculation done. The bottom is given as it is. We don't need to do anything. But the problem here is volume is given is in milliliters. 400 milliliters. But we want it in liters. So I will give you the conversion factor on the 1,000 milliliter or 1,000 milliliter. American way of saying this is European. They say 1,000. In America they say 1,000. 1,000 milliliter is 1 liter.
0.4.
Yes, 0.4. So if I want to set it up for some of you that this is so easy that even I feel, so it's given information is 400 milliliter, put 1,000 milliliter goes on the bottom, and 1 liter goes on the top. This I will give you on the test, you don't need to remember this. So it's 0.4 as I already mentioned.
Angela.
Why do you keep kicking?
Oh, you mentioned, you said 0.4? Maybe your voice sounds similar from behind. All right, so now this is where students, let me put a red mark here. Now this is not just your class because I haven't seen you do these problems yet, but they don't convert. They simply take that number and divide by 400. That's incorrect. So you have to do this conversion. Now it's all coming together as one piece. So molarity equals. If there is a problem that I didn't cover on the homework, don't panic. We can do this on Wednesday and then wrap it up. So molarity would be, you put the top number, which is 0.05 moles, and then bottom volume is 0.4 liters. As I said, when you're done with your calculation, this is what you want. If you don't have it, that means you're, like I said, students simply take the 400 and put it here. That's incorrect because it must be in liters. Does anyone have an answer? Good job, everybody. That's it. Now, how easy was this compared to the conversions we did on the previous one? That's what I said. But then, we struggle hard to get to the gram to mole idea ingrained in our brain, not this problem. Okay? So that's how you do a molarity problem. Does anyone need time to copy or want to take photographs? I can erase and do the next. 1 kilogram or kilogram of solvent. Let's just take that one. There's a major difference between molarity and molality. If you compare those two things directly, the top part is the same, which means whatever calculations we do for the top part for the molarity is same as for molality. But for molality, the bottom is not expressed in liters, it's expressed in kilograms. If some of you are wondering what this is, it's kilogram. Again, I'll give a conversion if needed. You don't have to memorize it. So let's do a problem that involves molality. I don't think I gave a question. Oh, there is one more. And there's one more. I will get to it in a second. I thought I put a question in there. Oh, yes. Question 13. Let's do the actual question here so that it's on top. So anyways, that's the definition of a molality is. 13 is an easy problem, but you have to again do conversions like we did on any other problem you've done so far. So it's problem 13. I don't want to write the entire question. I'll read and then write down what is needed. You're asked to calculate the molality of sulfuric acid, which is another acid we have not seen in class. I'll bring it next time. As soon as I open the bottle, you'll start to see white fumes coming out. It's probably one of the most dangerous acids. I'll bring it to class, show you next time, so you can get a feeling for what it looks like. You open the cap
You and
of
this
the
dangerous stuff.
container, you'll see white smoke coming out of it. It's extremely, extremely powerful acid. So a sulfuric acid solution contains 571.4 grams of H2SO4. Okay? Normally when they give you a mass and the name of some compound, that is usually the solute. There is no magic involved there. Now here's where some of you might need to use some of your math that you're learning. As a density, so this is mass is given. Density is given as, and now again I will keep this to American units, so 1.329. It's given as gram per centimeter cube. This is same as writing 1.329 grams over milliliters. I'll show you a video next time of how an English professor talks in a classroom and how an American professor talks in a classroom. It's only a 1-minute video, so we're not going to sit there and watch it for hours. Just how they talk and how their students react to it is very funny, because this is how an English professor would talk. And it's very difficult if you don't know these things. But if you go to Great Britain and study classes, it's going to be this way, this format. If you study in the US, it's this. So I'm going to give this to you on the test, because we are in America, we're not in England. So we have to calculate the molality. Now let's first do the easy part, which is getting the top of this problem, which is moles of solute, before we crush our head towards the last part of the problem. So let's get the moles of solute.
You got like 6 minutes before I run out, and I need this.
Run out of what? Battery?
Mm-hmm.
Well, this is the last problem for the day.
Okay.
So we'll be fine. And I'll try to do it within 60 minutes. So moles of solute is, well, we got 571.4 grams of H2SO4. That's the given information. Okay. As I said, solute is typically some value with a gram and the name of the compound. Again, same thing. Sulfuric acid, I believe, is 98, if I'm not mistaken. Sulfur is 32, 4 oxygen is 64, and 2 hydrogen is 2. So that's 6 times 3, 9, plus 88 grams. So 98 grams. This part is exactly same like the last problem. So can anyone give me what the mole value is? 571.4 grams divided by 98. What's that? 5.8. So on this molality problem, we know this. We're going to also do 14 if any of you want to stay.
Mhm.
That is also a molality problem. We're going to do. There's two ways to solve molality. So we know the top. If we can finish the bottom, we're done with the problem. So I'm going to erase all this and just leave the density alone here so I can come back and solve it. Okay. Now, we want our bottom to be just kilograms. That's what the only unit we want. So when you're done with the molality problem, the top should be moles, the bottom should be kilograms. Well, we're good for now. We got the top done. We got 5.8 moles. We just need to somehow convert this to grams over milliliter. Now, if I ask this very similar or type of question, what I would do is give in brackets, assume, you will see this on this question. Assume the solution, you don't need to write this down, I will give this, assume the solution density is similar to water's. You do not have to write this. This sentence will be in bracket if this type of problem for this particular case was on the test. Again, it will be on the practice test next week. Similar to density of water. You don't need to write this down. This will be in bold font because without this assumption, I didn't put it here because I want to emphasize the fact that this will be given. That's why I didn't put it here. So all you are going to do is if this density is given is you're going to say this is same as writing 1.329. Again, I will give this in American units, not in centimeter cube. But I do want to point it out. That's why I gave that. Is how students learn differently in the two countries. And probably the rest of the world uses this. Only America uses this. Well, we're not going to do much about it. This is the way we're going to learn. So you're simply going to say this is same as 1.329 grams. Just get rid of the ml. Okay? That's because I gave this assumption. You don't have to copy this now. This will be in brackets on this question on the test. Because without that assumption, I don't think you can do this. So all you're going to do is chop off this milliliters if any of you want. Why I'm doing it, I'll give you the answer in the next class because we're running out of time and I really want to finish this last problem. So the rest of the calculation is here because I don't want to go any below that. So we know the moles is 5.8 moles. We know the top. But we know the answer is in the bottom is 1.329 grams. But we got to go to kilograms. So 1,000 grams or 1,000 grams is equal to 1 kilogram. This is again English, European, this is American. So 1,000 grams is 1 kilogram. So 1.329 grams would be 1 and then 1,000 grams over 1 kilogram. So that would be what? 0.001329, right? This question is easy if I give you all that assumption, and I will give you that because there's no way we're not doing a real experiment in classroom. So just like how on these you see that I gave the conversions are in bold letters, for this particular question on molality, I will give you that statement in a bracket. What that allows you is chop off the milliliter and write the same value in grams without this. Now, without the statement, you won't be able to do it. Doing that without the statement is incorrect, but I will give you the statement for the molality question. So all you have to do is chop off this milliliter. All right, so let's complete the problem. Moles of solute equals, or molality equals moles of solute is 5.8 divided by the kilogram of solvent is 0. So what's the answer?
4360.
4364. That's it, moles over kilogram. If any of you want to stay 5 minutes, I will do a different version of 14, which is much easier because you don't even need the statement. It's already in kilograms. So let's finish that so that we will be done with